Hey guys, today we'll be looking at another Leet Code problem, which is problem number 9, called as palindrome number. When you usually solve a palindrome with a string, it's pretty straightforward. But in the follow-up section of this problem, we are asked to solve this without converting the integer into a string. So that makes it quite interesting and challenging at the same time. So first of all, let's try to understand different test cases before jumping into the problem. So I have put different values of x here, and then we can analyze whether it's a palindrome or not. Visually, when we see 121, we know that the reverse of 121 is also 121, so it's a palindrome integer or a number, so it's true. A negative 121 is not a palindrome. Similarly, 10 is not a palindrome number. And if you look at 1, 2, 3, 2, 1, it's a palindrome. Now let's talk about the approach. The approach of reversing a number is quite different from reversing a string. So pay close attention to what I'm doing here, and then we'll try to understand how we are going to reverse it. So first of all, let's assign a variable called reverse integer and assign it to a value 0. Okay, and now the original value x, let's take an example of 121. Uh, so if you have an original value of x 121, the idea is to start splitting the digits from the right hand side, which is units, tens, hundreds places, and then we are going to add them to the reverse integers value here. So the first and foremost thing that I'm going to do is uh, I'll create I'm going to split 1, which is in the units place, from 121. The way I can do that is, let me call this a digit. This will be x percentile 10, which is going to um, get the remainder when we divide x by 10. So which is nothing but 121 percentile 10. So this is going to be 1, right? Because when we divide it, it's going to be 12 and the remainder will be 1. So we want the remainder here. And now that we have the remainder, we need to add it to our reverse integer. And the way we add it to the reverse integer is we multiply the current reverse value to a 10, which represents the each units which is of base 10, right? Each digit. So reverse into 10 plus we are going to add the current digit to it. So what this means is um, reverse is currently 0. 0 into 10 is 0. Uh, 0 times 10 is 0 plus a digit that we're going to add is 1. So that means the total or the current reverse integer is 1. Now, what we're going to do is we need to reduce this number somehow to a smaller value. And the way we do it is to remove the units place completely, we need to divide it by 10. So x equal to x divided by 10, which is which needs to be put into %, so that we do not care about the decimal. We only care about the number before the decimal. So what this is going to result in is 12, right? And then we are going to continue with this. So till x is less than 0, we're going to continue these 3 steps. So now I'm going to do, now x is basically 12, right? Now we need to do 12 percentile 10. So we need to remove 2 from we need to remove the units digit 2 from 12. For that, we are going to do another percentile 10, which is going to give us a remainder of 2. Similarly, now we have split the digit out. So we're going to we're going to use that in the formula where the reverse, which is the existing reverse value is 1 into 10, which is 10, plus 2, that is 12, right? 10 plus 2 is 12. So that's the reverse value so far. Now we need to further divide 12 into a smaller value. So x equal to parse int of x by 10. So that's going to give us with 12 by 10, right, which is 1. When you do a parse int, it's going to be 1. So 1 is still greater than 0. So we are going to continue to perform these 3 steps again. So x percentile 10. So 1 percentile 10 is 1. And then reverse, the reverse right now is we have 12, right? 12 is the current reverse value. 12 into 10, which is 120, plus the current digit 1 is going to be 121. So that is the reverse value currently, which is 121. And then we are going to divide x into a smaller value, which is we're going to parse x by 10, which is going to take it to 0.1, which is less than 0. So that means we can stop repeating this process and we need not do this process again. And whatever is there in the reverse, we are going to compare it with the original value x. If these two are same, then that means it's a palindrome. So that's how we are going to approach this problem. I'm going to be writing the function right now, and let's start off with covering the base conditions. So base conditions, you can figure it out by looking at the constraints. So I'm going to say that if x is less than 0 or x is less than greater than 2 power 32, we are going to straight away return as false. It's not a palindrome, or it's out of bounds, right? Basically, it's out of the constraint, so we are going to return it as false. Only if it falls between these two values, we are going to even process this function or number. The first and foremost thing that we would like to do is we are going to retain the value original number to x, because we need this for comparison at later point of time as we are manipulating x in each step. Okay, so we have this, and the second thing that I'm going to do here is reverse int, which is going to be initialized to 0. Okay, all right. Now I'm going to have, since I'm repeating this set of steps, I'm going to put them within a while loop, and my boundary condition is while x is greater than 0, I'm going to keep repeating these steps. So I'll have my const as const digit equal to x percentile 10, and then what I'll be doing here is I'm going to update my reverse integer uh, with the same formula, reverse integer into or times 10 plus the digit, and then the last step is to update the original x. So I'm going to do x equal to % of x divided by 10. All right. So this is going to be continued till x is less than 0. After x is less than 0, I'm going to be just returning if original number is equal to reverse integer, I'm going to be returning a value of true. Otherwise, it's going to return a value of false. Okay, so let's try to run this solution. Okay, so we can see that it has worked for the three base cases, 121, negative 121, and then 10. So let's add two more cases. Let's go to the test cases and add a value of 0. Okay, it has passed. It's going to be true. Also, let me add a bigger number, 1, 2, 3, 4, 5, 4, 3, 2, 1. Okay, looks like we have all the cases covered. The negative value, a regular value without a palindrome, and then a 0, and then a bigger number with odd number of digits. So I'll go ahead and submit it, and our solution has been accepted. So this is how we can reverse the digit and also compare it whether it's equivalent to the original number or not. So that's the conclusion of palindrome number solution. If you like this video, if you learned something from this video, please subscribe to my channel. Also give this video a like, and I'll see you in the next tutorials.